today's class, let us look at the critical points and stability for linear system. So we were seeing the general system of the form dx by dt equal to f of x by dy by dt equal to g of xy. Here f and g they can be either linear or non-linear functions in x and y. So it can be in the form ax plus by and cx plus dy, and then it can be any other function involving x and y. So using phase portraits, using the paths traced by the solution curves x equal to x of t and y equal to y of t, we have analyzed how to obtain the different types of critical points and how to define stability. So in today's class, we will be looking at a linear autonomous system. That means we are going to consider the system of the form dx by dt equal to a1x plus b1y and dy by dt equal to a2x plus b2y. Now for this system, we'll analyze what are or how to find the different or types of critical points, or how to classify the critical points, and we will analyze the stability for linear autonomous system. We have seen how to find the solution of this linear autonomous system. So we'll take the solutions in the form x equal to a e raised to mt and y equal to b e raised to mt. So we'll be obtaining a quadratic equation. അതിൻ്റെ റൂട്ട്സിൻ്റെ റൂട്ട്സ് റിയൽ ആവാം, ഡിസ്ക്രിപ്റ്റ് ആവാം, complex roots ആവാം, they can be equal roots. So depending on that, we obtain the solution. So same way, depending on the nature of the roots of the quadratic equation, we will classify the critical point into different categories. Now from here, we know that so by critical point, that we mean that is a point x and y which satisfies the equation a1x plus b1y equal to 0 and a2x plus b2y equal to 0. So obviously origin will be a critical point. Now throughout this section, we'll assume that this determinant is 0. Okay, so that means such a system has only the trivial solution. So when this determinant is equal to 0, the only critical point will be the origin 0, 0. So for that, we will make the analysis. Okay, so we'll be taking this kind of linear autonomous system. So the only critical point will be 0, 0. So we'll analyze what is the nature of the critical point 0, 0. Now let us start with the solution of the form x equal to a raised to mt and y equal to b raised to mt. Now upon substituting this into the linear system, we got the auxiliary equation in this form. നമ്മൾ ചെയ്തതാണ്. അപ്പോൾ നമ്മൾ ഇത് സോൾവ് ചെയ്യുമ്പോഴാണ് നമുക്ക് റൂട്ട്സ് കിട്ടുക. Now let me take m1 and m2 be the roots. So m1 and m2 be the roots of this equation. Now let us look at the nature of the critical point using this values of the roots. ഇനി നമ്മൾ m1 m2 എടുക്കുമ്പം they can be real and distinct, they can be real and equal, or conjugate complex. So depending on these values, we will get the different natures of a critical point. So we have a node, we have a saddle point, we have a center, and we have a spiral. So let us see when do we get these cases. So when the roots m1 and m2 are real, distinct, and of the same sign, in that case the critical point, the origin will become a node. In that case m1 m2 റിയലും ഡിസ്റ്റിങ്ക്റ്റും രണ്ടും ഒരേ സൈൻ ആവുമ്പോൾ, that means they both are positive or both are negative, then 0, 0 becomes a node in that case. Now if m1 m2 are real and distinct and are of opposite signs, we will be getting a saddle point in that case. And the third case is if m1 and m2 are conjugate complex but not pure imaginary. So it must not be pure imaginary. It means it must be in the form a plus or minus ib. Plus or minus ib form allenengil. So in that case, it will be a spiral. So the roots are complex roots of the form a plus or minus ib. Then we are getting the origin to be spiral in that case. Okay, and again when m1 and m2 are real and equal, that will be a node. And when m1 and m2 are pure imaginary, that means it is in the form plus or minus ib, then that becomes a center. So those are the cases. So when they are real, distinct under the same sign, that will be node. And again when they are real and equal, that will be a node. Then real, distinct and opposite sign, it will be a saddle point. Now if it is in the form a plus or minus ib, it will be a spiral. And if it is in the form plus or minus ib, it will be a center. So these are the different cases where we will get the different types of critical points depending on the roots of the auxiliary equation. So when you have a linear autonomous system, using the value of m1 and m2, we can decide upon what type of critical point do we get. Look at the proof for each case. So first we'll see the proof for case A. So case A is if the roots m1 and m2 are real, distinct and of same sign, then the critical point is a node. So we'll show that if the roots are real, distinct and of same sign, it will be a node. Now first we'll assume the case where both m1 and m2 are negative. So since they are distinct, one will be less than the other. So let me take m1 less than m2 less than 0. Now the general solution is, since the roots are real and distinct, so we'll get x of t equal to c1 c1 we'll get a1 is to m1t plus c2 a2 e raised to m2t, and y of t will be c1 b1 e raised to m1t plus c2 b2 e raised to m2t. Let us consider these cases. So we will take the cases where one is 0 and the other is not. So let us take c1 not equal to 0 and c2 equal to 0. Now when this happens, we will be getting x equal to c1 a1 e raised to m1t, then e term 0 out, and c1 b1. So y will be c1 b1 e raised to m1t. So that will give y by x equal to b1 by a1. So that will be a1 by equal to b1x. As you can see, this is a line which passes through the origin. So this gives dy by dx. So y is b1 by a1 into x. So therefore dy by dx will be b1 by a1. So this is a line with slope b1 by a1. So we will be getting a line of this form. Okay. So that will be passing through the origin. And now we have taken m1 to be negative. m1 negative ayathukonde as t tends to infinity, this will become m negative aanu, this will become e raised to negative term. So e raised to m1t will be approaching to 0 as t tends to infinity, since m1 is negative. Aduvale y also will be approaching to 0 as t tends to infinity. So therefore this is a line passing through origin with slope dy by dx equal to e1 by a1. Now since m1 is less than 0, so x equal to c1, a1 e raised to m1t, and y equal to c1, b1 e raised to m1t, so approach to 0 as t tends to infinity, because this is negative, so therefore the direction will be towards the origin. Now second, let us take the case when c1 equal to 0 and c2 not equal to 0. So we will be getting x equal to c2 e2 e raised to m2t, and y equal to c2 b2 e raised to m2t. Now upon dividing, we'll get y by x equal to b2 by e2. So this is again a line which is passing through the origin. So this is a line passing through 0, 0 with slope. Again, slope will be b2 by a2. Now since m2 is less than 0, as t tends to infinity, xy will be approaching to 0, 0. So again, here also we will get lines such that it enters the origin, and as t tends to infinity, this will be approaching to 0. അപ്പോൾ നമുക്ക് ആദ്യം കിട്ടിയ ലൈൻ ഇങ്ങനെയാണ്. Again, this line will be like this. Again, it will be entering the origin. Okay, so that will be the two lines are getting. Now let us consider the case where c1 not equal to 0 and c2 not equal to 0. ഇതിത്തെ രണ്ട് കേസിലും നമുക്ക് ഫസ്റ്റ് കേസിൽ c1 നോട്ട് ഈക്വൽ ടു 0 ആണ്, c2 നോട്ട് ഈക്വൽ ടു 0 ആണ്. അപ്പോൾ നമുക്ക് c1 ഗ്രേറ്റർ ദാൻ 0 വരുന്ന കേസുണ്ട്, c1 ലെസ് ദാൻ 0 വരുന്ന കേസുണ്ട്. അപ്പോൾ നമുക്ക് ഈ രണ്ട് ഹാഫ് ലൈൻസ് വരിക. സോ വി വിൽ ബി ഗെറ്റിംഗ് ഹാഫ് ലൈൻസ് ഇൻ ഈച്ച് കേസ്. അതുപോലെ ഇവിടെ c2 നോട്ട് ഈക്വൽ ടു 0 എന്ന് പറയുമ്പോൾ c2 ക്യാൻ ബി ഐദർ ലെസ് ദാൻ 0 ഓർ ഗ്രേറ്റർ ദാൻ 0. സോ ദാറ്റ് കറസ്പോണ്ട് ടു each of the half lines. So the half lines will be entering the origin, so that will give the respective lines with the slopes b1 by a1 and b2 by a2. Now the last case is when both are not equal to 0, c1 and c2 not equal to 0. Now when c1 and c2 are not equal to 0, we will be getting curves in that case instead of lines. So we'll get y by x equal to, so that will be c1 b1 e raised to m1t plus c2 b2 e raised to m2t by c1 a1 e raised to m1t plus c2 b2 e raised to c1 c2 a2 e raised to m2. Now let me divide throughout by c2 e raised to m2t. So that means here ഇവിടെ throughout numeratorലും denominatorലും c2 e raised to m2t കൊണ്ട് divide ചെയ്യുക. That will be y by x equal to